Okay, welcome to the class of kind of mixing a couple of things, but basically we're kind of crossing over from the material that you need to know for exam one into the material that you'll need to know for exam two. So there's a couple of things that came up both from an assignment perspective and from an exam perspective that I'm going to hit on today. A little bit of review, cover the rest of the stuff that's for exam one, and then I'm going to cross over into stuff that will be for exam two. So let's go ahead with that. So first thing, I think I mentioned this, but I think some people were not really clear on that. So they weren't quite sure how to edit an HTML file, save it as such, and then upload it into let's say your assignment, right? So you have to submit something for your assignment. I did check the settings for the assignment, so you can do an upload. I didn't restrict it to HTML, but obviously I do want them to be HTML. And I just want to kind of go here to explore. So if you're doing this on your computer, if I do this, you see this point here where it says your file name extensions. A lot of times your default computer installation will be not displaying your file extensions. And so you can see all of this doesn't have HTML after it, right? Your computer in the background knows that these are HTML files. So that's why it's showing like these little icon things here. And it knows something like this is let's say a text file or whatever. And then it knows this is a CSS file, but you can't see it because you don't see the extensions here, right? So you could work with it like this if you kind of know based on the icons what you're working with, and then you're going to do your right mouse button to do this, right? Because if I just double click on it, it's just going to pop it up into a browser, okay? But if you want to edit the HTML, you have to do a right, in my case, you have to do a right mouse into Notepad++, right? So I kind of think it's easier. So if you go into the view here and you go over here to where it says file name extensions, and you click on that, and you'll see this, right? And so there's a couple ways to do it. One way is to do it like this, where you create like a new, like this, and you can create whatever, right? But I might just say text document. Don't do rich text format, right? So do text document because that's nice and simple, no like formatting or anything inside of there. And then you can just go in here, and I just clicked on it a couple of times so I can change the name. Right, you can do a rename on it too, right? But I just clicked on it so I can go in here, and then I can, well, I already have a sample HTML, so I don't know, HTML, right? If I do that, it'll ask me change the file name extension and gives me a warning and stuff like that. Are you sure you want to change it? Yes, I want to change it, right? But actually I don't want to change it, right? You have to trust me. If I change it, it'll get to that, right? So this is like how you would create it, because I think some people were kind of stuck and they were just kind of taking pictures and sending it to me, right? So for your assignment, you need to send me an HTML file, right? Because your TAs are going to take your HTML file and basically click on it and just like render it on their browser to see if it works or not. And then of course they'll also look at the HTML in case they see something fishy there, right? So you do need to send in an HTML file. Do not take a picture and send in the picture, okay? I let you get away with sending a picture just for like my online assignments. And you know, some other people were asking me about the HTML. So the assignment one is HTML file. It's fairly basic HTML, right? It's kind of like the covers, like what was the first lecture I did on HTML. It doesn't really cover the more advanced stuff like the CSS stuff or the tables and the lists and whatnot, right? So in some ways, that's kind of why I asked you to send me like the in-class assignment last time to do the tables, and you know, really to kind of nest some of your HTML inside the table. So really good. There was like some people that went ahead and put in like images of flags and country flags and whatnot in there. Some people put in some lists in there. So that's really good. There's a couple of things that people didn't do, which maybe I'll just kind of build on a little bit and kind of kill two birds with one stone. You know, there was also some people are not quite sure what I meant by saying, floating, like float left and float right. So I'll kind of demonstrate that a little bit. And, some people weren't really messing around with the border here, but this is something else you can adjust, and I'll change that for you a couple of times to see what that looks like. And then there were some comments about, what exactly do you need on your HTML? Do you need like these semicolons and whatnot? And I was kind of explaining that's a little bit tricky. Like, you can say technically there's a lot of things that you can get away with not doing, even on the escape characters. But, in terms of like, quote unquote, best practice or whatever, it kind of suggests you do things. So it's to the point where you can debate it. Is it like just a suggestion? Is it a very hard suggestion or whatnot? And it's to the point where some things are even more than just best practice. They're not really enforced, but it's almost to the point where it essentially is required, right? Even though syntactically it doesn't break, it'll work. And I'll show you what I mean with that, okay? But first things first. So first thing is, I basically took the R, right, for Rutgers, and I set the image here. And what I'm going to do after this lecture, I'm going to just upload this sample HTML file so people can kind of see this and use this as examples, right? So here's like the float left here, right? So what does that look like? Let me just save this and let's go over to here. I think I already brought it up. Let me refresh it just to be safe. So this is what it means. So, I put in like the image for the R, like after Rutgers and College FSAS, right? Let me go back to here. So you see Rutgers, College FSAS, then I put in the image down here, and then I put on the others down here. So that's why it looks like that, right? So it starts off here, and then when I said float left, it stuck it over here, and then everything else kind of floated all the way around the outside, right? It floated off to the right. So that's what happens when I say float left, right? I guess this is something you could have tried on your own browser, but I'm kind of demonstrating now so you see what happens. Let me just flip that now. And I'm going to say float right. And there's only two things. You can either float left, or you can only float right, okay? So let's see what happens when I do that. So you see what happened, right? It went all the way over to the right side, and you'll see these guys, quote unquote, floating on the left, right? It's not really that apparent because I kind of kept these pretty short, but you could have just imagined like whatever image you have here, like all the other words will float to the left around it, kind of work its way around, right? It's a little bit more apparent when I stick it to the left, like I said, because these are like short text descriptions here, okay? And let me go back to here. So you can notice when I say the float right, I put the semicolon here. So let me come back to HTML here, here. All right, so this is W3 schools, and it kind of goes through a couple different types of things here, and I'll just kind of run through it pretty quickly with you to see what I mean by there are certain things you can do or not do, and it won't break the browser per se. It'll kind of work, but it's just not good practice to the point where some of them you can just say, actually, even though it's not really required, it is required, right? So this is saying HTML style guide and coding conventions, right? Coding conventions. So up top, and this is why I was kind of saying instead of using the HTML5 editor for doing your assignment, it's probably better to edit the HTML directly because the online browser doesn't require you to put this in here. But when you create an HTML doc, you should put that in here, right? Using lowercase element names, yeah, that's a convention, right? So they give an example here, good, right? So you can see body, right? P as opposed to this, okay? And then, this is one that's a very common thing, right? You can do certain things just like this, right? Where you don't necessarily close off your tag, right? And they give an example here with the P, and it doesn't break, right? But it's not really encouraged, right? So you really want to kind of put that in here so you can see, quote unquote, good, right? So you have the P and the closing P here, like that, versus this. Either case will work, but you really want to do it this way, okay? Attribute names, that's fine. And, something like this. Some of these actually, honestly, I didn't even think about it myself. I'm just kind of used to doing it a certain way, and I just kind of follow that without thinking too much. But like I said, they've kind of made certain things like very robust so that even if you don't do it, it still works, right? But stick with the convention here. Like I said, sometimes you don't know. Some of these things have been made more robust by using like newer versions, right? And that means it's actually not backwards compatible if you kind of just set up your format to be the newer versions. What happens if you somehow get mixed in with some of the older version? All of a sudden your thing doesn't work anymore. So even though like maybe some of the newer versions have accommodated and made things more robust, you may not take full advantage of it if you want to maintain backwards compatibility. Okay. I didn't talk about it too much, but when you put in your images, you can put in like your height, your width, and all that kind of stuff. Your spaces and equal sign and whatnot. Talk about the blank lines, indentation, stuff like this, right? Typically, you'll see like a table, you'll see like this little indentation example. You can see what typically a list will look like, right? So you have this tabbing and stuff like that, right? Here's another example, right? The title, okay? They're saying it's required in HTML. Well, you could create it without it actually, right? You're just going to end up with a tag with nothing at the top here, your title tab. It's not going to have anything there. And like I said, a lot of these things you put in there, like in the head area or this title area, this is important, right? Generally, we don't create a web page just for ourselves, right? We're creating a web engine so that other people can come and look at it, right? And so you want to have information. Yeah, you can use these to help with your assignment 1. So these are examples, right? That's why I'm kind of pointing it out for you. It's good to take a look at these things and use this. It's important for search engine optimization, right? That's usually why we create web pages, right? We want other people to know what's on the page and search on it, right? So here's a prime example where, yeah, I'm pretty sure I can like skip a title element. Your page will still technically work, but you lose things because you don't put that in there. And therefore, this is a strong statement to say never skip using a title element, right? So I'm just trying to distinguish between like something like this where you needed to get certain types of functionality versus a syntax error, right? So you can put in like, the HTML validator, some of these things will not pop up because yeah, technically the page does work, right? But you're going to be missing this, right? Is that good or bad? That's probably bad, right? So that's why, hence, that's why the title is required. Okay. So I hope you understand that little nuance or distinction as to why certain things are quote unquote required. You can do, I'm not going to go through this whole thing, right? But there's a whole bunch of these different things, right? Closing off, HTML elements, the language attribute, like I was saying before, a lot of these things, your page will still work, right? If you don't do it. So you can take a look at these. Some of these you can put in there if you want, like, I put it. So usually I might have something like this with the UTF-8, right? I'll kind of put that in there. I don't think too much about putting in this one, but yeah, fine. It doesn't hurt to put in there. In fact, yeah, go ahead. You can put it in there. And I don't really do anything with this here. But you can take a look at this. A lot of this is pretty relevant for what you're doing. Okay. So go ahead and put that in there. And then going back to here, someone asked me last time about the semicolon for the styles, right? And so, technically, if you follow that convention and you're consistent with it, then when I put in a floating style, even though some of the examples show it without the semicolon, well, I'll put in a semicolon, right? But I can put it either way. It doesn't matter, right? It'll work fine, right? So I put it in here. You can see it worked fine, right? Take it out. it still works, right? No problem. I do this, and where's my page at? Over here. And yeah, no problem, right? It's the same thing, right? So I'm not going to beat a dead horse with this. I'll just leave it at that. Let me go down to here. Like I said, some people didn't really do it, so let me just do it here and people can see it. You know, the border is an attribute here, right? And I can set this. Let me set it to 5. And if I come back to here, before I refresh, you can see this is what the standard one will look like. You have to put something in here, otherwise you won't end up with a box here, right? See this box that, you know, all these cells? If you don't put any of that in there, you're just going to end up with these words kind of floating around. So you better put something in there, right? But now I put it in here, let me refresh it. So you see what happened? I made it a 5. It kind of made it thicker and kind of made it like sort of like this bold thing. It didn't have like that little space in between. So that's really like border, right? That's what a border is, right? So your border is this, like that. So that's what happens when I play around with this border here, okay? So this is fine. You know, you guys all did this in your online submission here. And then I didn't really go over this, but you know, in terms of like documentation, right? Sometimes you want to kind of do things that other people are going to be able to edit your web page. You'll create a web page, but you're not going to maintain that web page forever. There'll be other people that do it. Or maybe you're trying out some different bits of code, although you want to be careful with that to have too much code commented out, because then it gets confusing. But these are comments, right? So if you want to put some comments in here and saying, hey, we created this web page, I made some assumptions about the countries and the languages and whatnot. You put it all in here. You can see in my editor, it made it like this, like green color. So you can see that nothing is actually executing. This is really just comments, okay? And like I said, it's not usually good practice to do comments around code like this, right? Because even though it's color coded here, I can see the difference here. Sometimes you're looking at it, if it's like a whole bunch of HTML, a whole bunch of code, you confuse the heck out of yourself. You don't know whether it's like really like going to show up on the page or it's just commented out, okay? So this is like how you do comments here, okay? Let me go back to here, just run through this quickly. Was there any other questions that I got? Yeah, so there was the CSS. I think I showed you guys how to do the CSS file. The list tags, yeah, we did the list tags. We nested the list tags, right? We did the images. We did the float, right? So you had the floating for that. Yeah, so float left, float right, handling tables, call span, right? Call span for the heading, all right? Remember this, captions at the top. The heading is for the top row of the table, okay? And yeah, so that covers all of this. So this definitely is like a key part of the exam. So make sure you know all of these different things. And you know, there was some questions about the absolute and relative path names here. So, you know, kind of like what I was saying here, if you're doing something like locally here, so let's say I created like a new folder here, and I say like pics, something like that, right? So whatever HTML I have in here, I would just do .. /pics and then the name of the file, right? I don't have to go like C : you know, desktop HTML pics or whatever. So when I start with the C : and spell out that whole path, that's considered absolute path, right? And so what happens? Well, what happens if I would take this HTML folder and drag it somewhere else and put it somewhere else? Then all of a sudden, like all of my file references will break, right? So that's not good, right? But if I do relative path reference, so in this case, if all of the stuff in my HTML here goes to like .. /pics and the name of the file inside that pics folder, then I can move this whole directory structure somewhere else and nothing will break. Everything will work fine, right? But when you're going to a website, so when I'm going to like Rutgers, right, this senate.rutgers.edu, I have no idea where is this, right? So I need to spell out this whole thing to get to this JPEG file, okay? And so that's why that's considered an absolute path, which is your full path versus your relative path. So I hope hopefully people get that idea based on what I just explained there, okay? All right. Now, the other thing I wanted to just quickly hit on today, so, you know, some people are kind of looking at, so am I ever gonna like monkey around with a web page or whatever? So I just wanted to show you, I mean, I happen to kind of mess around with a few web pages. So one of them is like for a karate school, okay? And so, you know, it's one of those things, like this is a tool that you would use, right? Either to get information out or for your marketing. You know, you want to get people to come to your business, to buy whatever product, if you're running an e-commerce website and whatnot. You know, you have pictures, you have visuals here, right? Of course, you're not really doing this with your basic HTML. This is where you start getting into like using CSS, you start using like components and all of that, right? But this is where also the level of abstraction that we talk about. You're not going to be writing these low level things. You'll be kind of pulling these things together and using them. And there's like a lot of good editors right now that kind of put all these things out there together. And what you're doing is going to be just tweaking things, right? Kind of just adding some bits here and there and whatnot. And so this is where, you know, if you have a good understanding of HTML and later on JavaScript and how these things hang together, you can take whatever like the generic editors have done and go in here and play around with it. You can go in here and play, you know, connect things, right? You can add pictures, you can make it so that you can set up forms, right? So like if I have this, you know, you can do like sign up for our special now or something like that, right? And then you would click on it and, you know, you get your summer special, right? Blah, blah, you get this, here's a form. This would send out an email to me, let's say. I could set it up that, you know, you can register, you can, you know, pay for like a self-defense class or whatever. All of these different types of things here, right? So, you know, this is what you would do, right? For your, you know, if you're doing like a web page, you're running your own business, you're doing an e-commerce site, you know, you're running a blog, you know, whatever it is, there's a whole bunch of these different types of things that once you get to know how to do these things, you know, either you can do it yourself or, you know, you can hire, you know, someone to manage these type of things. And, you know, because you know a bit about this type of things, you can hold them to a higher bar, right? You can make it so that you say, hey, I know how, you know, HTML works. I know how websites work and whatnot. And so you know the different types of options that are available to you, okay? So just to give you a flavor of like how you might be using the things that we're teaching you in class right now, okay? So let me see here. All right, so I think I can close off chapter 4 right now. So where are we at here? So we're at the fetch, decode, and execute cycle, okay? So honestly, like, do you really need to know this to do a website? Probably not, right? So you don't need to know this stuff, but this is part what we have to teach. I have like condensed like what you have to learn, but this is an important topic that I'm supposed to cover for this class. So, you know, I'll go through it. So the way I like to look at, so, you know, in case it's not clear and people don't remember, this is at the chip level. This is at your CPU level, right? And I like to think of it as like if you're looking at a factory, right? And it's like a conveyor belt, like you're running along this conveyor belt and there's different things happening at each point on the conveyor belt. Let's say your conveyor belt, you're building a car or something, right? So, you know, out comes like the frame for the car, you start bolting stuff on there, you put the wheels on there maybe. Well, actually you don't put the wheels on there, but you put on the frame, you start to put all these different things, you get the car painted, then you start plugging in like, the mechanicals, the electronics, start putting in the glass, blah, blah. It's like going down this conveyor belt, this assembly line type of thing. And that's to me analogous to like what's happening with your CPU. Your CPU is like this factory, it's processing things. And there's like this constant stream of like requests and then processing and then output that comes out the other side. Okay, so hopefully that gives you a picture of what's going on here. So let me come back to here. Okay, and so I think I was at this point in the last class where we were talking about your memory. Here's your CPU, here's your secondary storage over here, or your storage devices. Here's your input output, right? And like your control unit, right? This kind of is like the supervisor, kind of tells what's going on, gets the resources, and then has like this worker bee kind of cranking stuff out, right? This ALU. Okay, so yeah, and I talked about the accumulator, right? And you're going to see more of this when we get into like JavaScript, right? This idea of like this variable kind of accumulating, right? Kind of keeps on going up or going down or whatever, right? If you don't understand the idea of accumulator, make sure you let me know later. Okay. So we start off with the fetch, right? So here's the fetch. Like we were talking about the recipe, right? What's the next instruction that you have to go and do, right? And your recipe, this program is sitting in like, the storage in the memory on your computer, right? So you have to go out there, you have to go and get it, and you got the instruction, right? And then you have to keep track of where you on the recipe, right? So you have this recipe, there's like, let's say there's 10 steps to the recipe. Which step are you on? You're on step 2, right? So this is going for step 2, and you have to increment it so you know that you're going to go to step 3, maybe, right? You're not always going to go to step 3, right? But you're going to go to maybe step 3, and that's where you have the program counter to keep track of what step you're supposed to be at. And then, there's this idea of like decoding everything, right? So you're going to be like, basically getting all this stuff into your local working memory, which is your register, right? So there's like this instruction register, right? And then you're gonna, this is basically getting the ingredients, right? You're going out to get the ingredients to work on whatever it is in your working memory, and then you're gonna do execute, right? So you have execute here. So you're gonna take the action of the instruction with the instruction register. Okay, so that's what they mean when they say the fetch, decode, execute cycle. Okay, just remember register is essentially memory, right? They're almost the same thing. The only difference is when you talk about register, they're like these high speed, like local memory for the CPU. It's right on the chip itself, and it's like their working memory. Okay, so this kind of goes through like this loop that we'll go through along this assembly line. So pretend this is like a factory, right? It's cranking this out, right? So you got the instruction fetch, you're going to decode that instruction, and then you have to get the data. You have to go to that. Remember, like last class I was talking about, you have to go to the refrigerator, you have to go get the data, and then you have to get the operating fetch. What are you going to do? Are you going to add these two numbers together? You're going to subtract them? Like, what are you going to do? So that's like getting the ingredients and what you're gonna have to do to those ingredients, right? Then you have to execute it, right? Once you're done executing, then the output has to go somewhere, right? So you're gonna take out the output, and then it will probably end up going to like your RAM, okay? And then it goes right back to the top and gets the next instruction, okay? So hopefully between these two things, you get a clear picture of this loop, this cycle that it goes through, okay? So this is kind of breaks it down. So you have, you're gonna do a multiplication. That's what this MULT stands for, right? So you're gonna multiply a couple numbers, okay? And the numbers are gonna be stored, it's kind of arbitrary, but saying these locations, right? Location 2000 and location 2080, okay? And then you're gonna store it in this location, 4000, okay? So what you're gonna be doing, in this case, multiply, what you're going to be doing it to, which is these two things here, right? In these two memory addresses, the value is actually not 2000 and 2080. These are the memory locations, right? And then the output from that goes into this memory location, okay? So this is essentially low-level computing instructions, right? Usually when you write a programming instruction, you're not going to be at this level. Your computer is going to translate what you write and break it down into these very small bits of instructions, and it's multiplied by many thousands of lines for the one line that you might be writing, okay? So there's this idea of a clock, right? Which these days it's very fast compared to the old days, right? So you can picture it as like it keeps the rhythm, right? So everything kind of works off of this clock. Otherwise, you're going to get like some bad things happening, right? If the clock is, let's say, running, at one speed and it's not in sync with what all the other things in the computer are doing, then it's going to be a mess, right? It'll be like, like a city with all these blocks and cars running around without traffic lights, right? So you have to have like some sort of clock that will keep all the different things that interact with the computer in the computer at the same rhythm, right? At the same cadence, right? So that's why you have this idea of a computer clock, right? And as the chips have gotten better and the technology has gotten better, these clock cycles have gotten faster and faster, right? And so this is generally where you're at right now, right? You're talking about billions of cycles per second, right? When we talk about a cycle, that's a cycle, right? So every time it goes through, that's a cycle on your chip, on your CPU. Okay, so when you're talking about like how fast things are going, generally this is what you're talking about in terms of gigahertz. Okay, and so I'm gonna try to see if this makes sense to everyone. This kind of lines up to like the whole idea of like this assembly line, right? So, you talk about like a clock, one cycle per clock tick, okay? So let's take a look at this. So you have like this instructions coming in like this, right? Comes in during the fetch phase, right? And at the same time, up here, you see like the first instruction got completed, okay? So, but you can see like, if you actually do it this way, there's maybe some inefficiencies, right? You can almost picture like what I was just telling you about the assembly line. Just picture that you shoot like one car, you're building a car on that assembly line, and before you start working on your next car, you wait until that car gets all the way to the end, right? So, remember I was saying that you put in the car and like each slot is doing something, right? Maybe the first slot, sets up the car to get painted. It gets painted. Then you start putting in like the mechanicals and the electrics, the electronic stuff, and then you start putting the window in and blah, blah, like all the way down the line. And, each step along the way, becomes empty after it's done, right? So after I got done painting the car, I'm just sitting there waiting until it goes all the way down to the end of the line. The car is done. And then someone goes out to the front of the factory and says, okay, send in the next, next frame for the next car, and let's start working on that. You can imagine that sounds pretty inefficient, right? You're not going to really want to do that, right? And that's why you look at this thing where it says like process cycle with pipelining. This is where you try to fill up every single slot of your assembly line. Okay, so in this case, you can see like instruction one. Let's say this is your first car going through your assembly line, right? While it's processing, when it got to, let's say, this second step here, you already started working on your instruction two, right? And so on and so forth, right? So by the time you get to the end, so this one is, let's say, your first car about ready to roll off your assembly line. Right behind it is your second car, and then right behind that is your third car, and then right behind that is your fourth car, right? So you can see you're getting more instructions in in the most efficient way. You're maximizing utilization of your computer chip or your assembly line, right? As opposed to doing this, where you wait until it goes all the way to the end and then say, okay, go get the next car, right? You can see there's all this empty space here. And you can see in the same time that you took the process instruction 1, you're already like 3/4 of the way with instruction 2, and you're already like halfway done with instruction 3, and you've started instruction 4, right? Versus like this, you just got done with here, and then all of a sudden you just only gotten started with instruction 2 after you get to the completion of the car. Okay, so hopefully people get what I just said in terms of why you do this thing called pipelining, right? So number one, the idea you want to get is that each one of these fetch execute cycles will take up these 4 steps, right? And to optimize per clock cycle, you're running gigahertz, right? A lot of clock cycles, right? But even then, you still want to optimize. You want to make the best use of your processor. And you do that by doing this pipelining, okay? Now, I just kind of explained to you, this is like the ideal situation. Now, in practice, do we actually ever get to fully do this all the time? Maybe not, right? Because not everything lines up so nicely, right? Sometimes you have an interdependency between one instruction and another instruction. And so you can't start the next step until you get something out from the first step, right? You need to get the result from the first step before you can do something for the second step, let's say, right? So you cannot always do pipelining, right? And then there's another aspect is, what I was saying before, when you look at your program counter, do you go from step 1 to step 2, step 3, step 4? Maybe, but sometimes you might jump to another area. You might go from instruction 2 to instruction step 8 or something like that, right? Because there was something that happened in instruction 2 that told you you need to skip the other steps and go to instruction 8. So if you don't have that type of predictability of what your next step is, again, you might have difficulty to do pipelining like this, okay? So hopefully people are understanding what I was just saying there in terms of like how the clock cycle works and how you optimize it by doing this thing called pipelining, but you cannot always do pipelining, right? You might have some challenges to do pipelining, exactly what I was saying, where you might jump instructions, you might have dependencies from one step to another step, okay? Memory I've talked about, I think people are clear on that. Hard drive, external memory, yeah, a little bit slower, right? These days, like a lot of things are probably like SSD. So you're gonna get a little bit faster than the old days when you had to go into your hard drive all the time, and God forbid you had to go into a floppy drive or something like that. Painfully slow. So a lot of the computers now, if you get a new computer, generally, unless you're trying to save money or something, you're probably going to get like a SSD, which will probably be relatively good performance, right? And you get a decent amount of space for that. Okay. So this talks about memory locations. I'm not really, sure if there's much more to this. So each one, this is similar to what we were talking about. You guys remember the RGB, right? Red, green, blue for the colors, 1 byte each, right? So 1 byte is kind of like this very common number. So 256, again, it's a very common number when you're working with computers. So this binary, so 2 to the 8th, 1 byte, and you can imagine if you're storing stuff in memory, at least from your perspective, it would kind of look like this. Okay. Okay. Many simple operations, which is kind of like what I was showing you up here with this, with mult, right? So what you type in at the high level, that's high level, that's level of abstraction. You're working with things at a high level because people can read it, right? People are not really going to read this stuff all the time, right? When you actually get into like a whole bunch of zeros and ones, there's no way like a person is going to be able to read that at scale. Okay, so but it's many simple operations that's what it ultimately breaks down to for the computer. And again, this is just another reference to software layers, right? You remember what we were saying, like this is the operating system. This is low-level stuff. This will be drivers. Remember the idea of drivers, right? That's like how the computer can talk to different things. It can talk to your monitor, can talk to your printer, your mouse, or keyboard, or whatever, right? It's basically software that allows your computer to control these other hardware things. Okay, so that's what a software driver is. So I mentioned again, I know I mentioned it last class. That's one of those terms you should remember and know. Okay, that might pop up in your exam. Okay, so remember software driver. Okay, common language runtime, right? Again, these are fairly low level stuff. You guys would never really be working at this level, but all of these different levels here is essentially translating, if you were a programmer, what you're doing here to do stuff on the computer, right? To order the computer to print something or whatever, right? And you have all these different levels. Depending on which level you're at, you will get either, you go higher up to get ease of use, right? So it's easier for a programmer or a person to work with certain things at a high level, or you want to get more control, right? So that's the trade-off, right? If I want to be able to control specific things, I want like to get like my own special behavior on how like something gets printed, then I'm gonna have to work at this level, because you're not gonna get that type of capability or power up here. You need to kind of work down here. Okay, so software layers, it's the same thing. It's like when I talk about levels of abstraction. Okay, so let me go through here. I think I kind of went through all of these and gave you some examples here. So remember program counter, so branch and jump instructions. This is what I was saying. Like if you're at step 2, there could be something that kind of says, like, based on this result, I need to jump to another location, right? So if my number is less than 0, all of a sudden I owe money, right? It goes negative, right? That means I'm not going to be allowed to take money out of my bank account anymore because there's no money in there, and they'll jump to something else. Like they'll tell me, hey, you have no money, something like that. Versus like, I do have money in my bank account, then it'll continue processing to, let's say, step 3 to kind of say, oh yeah, you can take out, $100 or whatever it is, right? So that's what they mean about branching and jumping, right? So there'll be some sort of conditional logic that will determine whether you're going to go to the next step or you're going to jump 5 steps ahead. Okay. Instruction and interpretation, that's part of the fetch execute cycle there. The computer clock, remember, everything is synchronized to the computer clock. That's how we make sure there's no like weird behavior, no collisions and whatnot. Things are synchronized. And then each tick of the clock, that steps into the idea of the pipeline, right? So try to understand what I just said in terms of the pipeline and why, pipeline is better than just running one thing through the factory and then shooting the next thing in through. You're kind of running these things in sort of parallel mode, right? It's not quite parallel because, you're basically filling in each bucket within the assembly line. So it's kind of one right after the other on the assembly line. Okay. All right. So what I've just covered here is really everything that you want to know for the first exam. All right. So let me just go over to here, and course objectives, part 1. Just open this up. Let me zoom this a little bit. Boom, boom. We did 7, 8. Got these resources here. Chapter 4, which is a big meaty one, that's your HTML. 4, 1, and 9, right? Remember this, right? Just remember what these guys did, right? Don't have to worry about anything else except that, right? So father computing, punch cards, the census, right? Internet, right? Remember this, right? CPU, memory, secondary storage, right? The purpose of layered software development, which is what I just talked about. Go through this. Device driver, which I just mentioned here, right? What's a peripheral? Yeah, all of these different things here. secondary storage, right? What I was saying, a hard drive versus like, solid state device, right? Um, this is better, right? This will be faster, right? Because you're not kind of writing to a disk or something. So this will be a lot faster, and it's more accessible now because of the way prices have gone down. So you can more easily get SSD for a reasonable price. Okay. So anyway, so I'm drawing a very clear line here. Everything up to here is for the first exam. If there's any questions about the material there, anything I put out on the sample questions that you have questions on, drop me a line. I'll do some office hours, 3 to 5, and we're good on that point. Okay. So before I go into the second part, which will be the second exam part, it's not something you need to stress out with too much right now, I guess. So what I'd like to do, and I kind of mentioned this at the beginning of class, is that we do collect feedback from everyone, and we try to get feedback that we can act on, right? If you just kind of say, yeah, the class is good or bad, well, okay, that doesn't really do me any good, right? But if you kind of talk about different things, well, oh yeah, it'll be good if we can kind of, get this laid out on the canvas so that it's better organized and we can access information better, then that's great. I can act on that, right? So we've kind of had a couple of different things where people have given us feedback on how we can restructure the web page. All of that type of feedback is actionable feedback. And at the same time, I think I also mentioned this at the beginning of class, for you to benefit, it would be good for you to, send feedback to me such that maybe I can make a change in the class right now that will help you. Okay. So, I think part of my in-class assignment for today won't be for you to write HTML or whatever. I think we did a little bit of that for the last class. Just send me an email, with some of your feedback, whether you like things, you would like the layout of the materials, whether things are being explained well or not, suggestions you have, and I'll do my best between myself and the TAs to get back to you and maybe actually improve the class now instead of waiting until the next semester to incorporate your suggestions. So for the online work for today, that's all I'm going to ask you to do. Just send me an email with your suggestions, right? What do you like about the class? What do you think can be improved with the class? And like I said, I'll read all of the feedback and do my best to, shape the class and make it better, right? And hopefully you get something out of it. So that's my online, homework or online assignment for today. And we're going to take like maybe a 5-minute break. So it's 6:50 right now. So let's say come back at 6:55 and my in-class assignment today is to send me that feedback and suggestions, okay? And I'm going to also answer some questions that people are sending to me on chat. So I'm going to do that right now, but I'm going to turn off my camera and my mic until 6:55, okay? Okay, so here we go. Yeah, I see people are sending me some emails and putting stuff on chat about the whatever assignments and exams. So I'll answer them. So send them along however way you like, and I'll get back to you as soon as I can. So here we are. We got chapters 10 and 17. So these beginning parts are basically almost just like review, right? Like I said, this is kind of like crossing over between exam 1 to exam 2. So just like a refresher on things. So chapter 10, right? The idea here is algorithmic thinking. Okay. So, you know, what do you think about in terms of like an algorithm, right? So you talk about like, and again, I'll draw like some analogy to like your recipe, right? So you're gonna have an algorithm to bake a cake, right? So what are the ingredients that you need? Your output is a cake, right? I guess, and it's something tangible, right? Like, you know, and you're gonna say, you know, every time I run this algorithm or this recipe, am I gonna get the same thing, right? And is there like a definite end to it? Is there a thing that I can say, okay, I have a cake that I can eat or something like that, right? So that's what all these different properties are for algorithm, okay? And I'm gonna go into that in a second here. And then you have a heuristic process. Heuristic process is like a rule of thumb, right? It's like a quick and dirty way. So you guys probably all know this, like, you know, probably many of you in the business school. So you're probably thinking about like, you know, let's say the rule of 72, right? To figure out like how quickly your money can potentially double given a certain rate of return, right? That's a very quick and dirty way. Is that 100% accurate? No, it's not exactly that, but it's good enough, right? For a lot of people for a quick and dirty calculation. So that's what they mean by heuristic process, right? So something quick and dirty, rule of thumb to make a quick decision and whatnot, but people know that it's not like, you know, super accurate or 100% definite, right? And then you have flow charts and then pseudocode, okay? And so all of this stuff kind of feeds into your assignment, your next assignment, okay? So yeah, programs are algorithms. Programs are telling the computer, just like a recipe would tell you how to bake a cake, the program is telling the computer how to do whatever, right? If you want the computer to do something, that's what these programs are doing, okay? So, but you have to define a lot of things, right? So a specific set of conditions that, you know, you need to achieve whatever you want the computer to do, right? So, you know, there's some like examples here, kind of like things that you have taken steps to convert something, right? So converting binary to decimal, right? So first step for the place value, remember this for your for your binary, right? For your binary conversion, right? So 2 to the 0, 2 to the 1, and so on and so forth, right? And you put in a 1 for that value, and then if there's a 0, nothing, right? And then you're going to add up all the place values. That essentially is the steps that you would follow to convert a binary number to a decimal number, okay? Albeit like it's not 100% specific. It's kind of really assuming that, you know, like in the background, you have to have like these 2 to the exponents to line up all of your numbers for your conversion, right? It doesn't really say anything here. It's kind of assuming that you know that, right? But you get the idea, right? There's like these discrete steps that you're following and they're reproducible. It's not like, well, if you do this today, you'll get one answer, and you do this tomorrow, you'll get a different answer, right? So these are concrete, discrete steps that you follow it, and each time you follow it, you'll get the same exact result, right? You're not going to get like result one day, and then you put in the same input, you get result 2 like the next day, okay? So all your inputs, assuming the same inputs, you're going to get the same output, right? and then down here, like I said, I've been referring to recipe a lot, right? But you have like, IKEA putting furniture together, right? How do you do laundry, all that kind of stuff. Like these are all like essentially programs that we follow to get things done. Okay, so that's analogous to what the computer is doing with the program. Okay, yeah, so this is not really an algorithm, right? It's a free-for-all, right? Everybody just kind of chucks themselves into this little circle, and whoever can have the nerve to squeeze their way through there will come out the other end, whichever end they're trying to go to, right? Yeah, probably an example of like not a good algorithm, right? Essentially no algorithm, right? Maybe. So here we're talking about algorithm versus heuristic process, right? And like what I was saying before, heuristic process is essentially like a rule of thumb, right? It's not quite as precise as looking at an algorithm, okay? So yeah, so not all the processes in the book are algorithms, right? That's fine, right? And yeah, so here's a good example, right? So to find information on the search engine, right? There's not like really this hard and fast rule to kind of say, okay, you need to do some search. There's exactly what you're going to do, but you have a general idea, right? So you might say, oh, I'm going to search for tigers, right? And so you type in tigers and boom, you got that, right? But something more complex, yeah, maybe you get something, maybe not. So those type of thing is more of like a general type of heuristic, essentially, right? Coming back to heuristic, right? So this part, helpful guide for finding a result, right? And it's an approximation, right? It's not like something that is like as precise as the algorithm, okay? All right, so these are the different things you're talking about when you're looking at an algorithm, right? Like I said, what is your input, right? So your input or your data that you're gonna need to transform, right? So if I have an algorithm to convert all of my binary numbers to decimal numbers, let's say, so your input would be these binary numbers, right? The data to be transformed, right? And so this is the data that you need to get the result that you want, right? You need input, right? So you need to know what kind of data, how much of that data, what form that data should be in, right? That makes sense, right? Unless you get that, you have no idea what you're supposed to do, okay? And then you have to say, well, what's the output? Well, in our case, our output, we're talking about like decimal numbers. We're trying to convert binary numbers to decimal numbers, let's say, right? So so the output of the data resulting from your computation, your intended result, in this case, we're talking about decimal numbers, right? In this case, they're talking about algorithm to compute the batting average, right? Or you don't even have to say batting average, right? You just say algorithm to compute average, right? How do you compute the average? And then you have the output precision, right? That you know what kind of data and what form the output should be, right? Like a batting, well, I keep on saying batting average. I'm just going to say average, right? To compute the average, like, you know what that should look like, what that should be. Same thing for, let's say what I was talking about before, converting your binary to your decimal number, right? So you have to have a feel exactly what your output should be. It can't be like this vague, fuzzy thing, right? It has to be a clear, discrete output that you're trying to get to, okay? So this idea of definiteness, right? So you have the algorithm at every step and the order that you have to take to process this, right? So you have a definite sequence, right? You can't do it you can't do it out of sequence, obviously, right? So if I'm going to convert or not going to convert, I'm going to, compute like the average, like the last example from the last slide. You have to do things in a certain order. You have to add the numbers and then you have to divide the total elements, right? So you have to specify the sequence for the operations for turning your input into your output. And, each step has to be spelled out, Okay. I'm not going to say you really have to include how to handle errors, but generally it is a good idea of the hand. It's kind of what they're saying, whether your algorithm is robust or not, right? You can put in like whatever type of algorithm. Let's say I say I'm going to calculate the average or something, right? But then I put in like, some characters, right? How do you calculate the average for characters? You probably don't, right? And so you're going to get unexpected results. Things will probably break. And so that's what they mean by including how to handle errors. Okay. Now, does that make it like an invalid algorithm? No. It doesn't really make it invalid algorithm. It's just not a robust algorithm. Okay. So when you say details of each step must be spelled out, that's obvious. You need to have the details. You need to know what you're doing with those numbers, right? And then this part, including how to handle errors, I would say this is nice to have. You want to be able to handle some basic error checking. And that's, to me, that's how you take an algorithm and make it a robust algorithm. Okay. I'm not sure how you take that distinction, but it is a distinction there, right? So effectiveness, right? So of course, each step has to be something that a computer can do, right? So it's not like you put it in there and then like someone else has to go in there and like give it some guidance or do whatever. It has to be like, I give it to the computer cranks through each step and comes up with the same result, given that same input every single time, right? It doesn't need me to kind of step in there to kind of like, add some more extra information or, say yes or no to certain things. It has no dependency on me or outside force, outside help. Okay, the computer can follow this algorithm without any help. Okay. Okay, so the algorithm should stop eventually. So meaning that you have to have some sort of output. It doesn't just kind of go away and spin forever, right? Or you're saying that it's going to infinity, right? So let's say you're calculating all the decimal places for pi or something like that. You know, if you don't do anything, it's essentially going to crank for infinity. You're never going to get a result, right? So you might say something like, okay, let me calculate pi to like 100 places or something like that. And then I get my definite output, right? My definite, my finiteness, okay? So, so you don't want to get into this like infinite loop problem, okay? And that's covering all of the 5 different aspects for an algorithm, okay? So you might have like, algorithms at different levels of detail. So like the example that we had before, we're calculating the average, let's say. So you might have something that kind of say, add like the top 5, not add, come up with the average of the top 5 averages for the class, right? So, you're not actually, well, actually that might not be a good example, but you're basically putting a layer on top of it, right? So the act of calculating the average. So let me add the 5 averages. Okay, so the average calculation itself, you don't have to necessarily know. You just know that magically someone is going to give you the average for that person in that class. Okay, so your algorithm could be working at the higher level, which will be, add these 5 numbers together or these 5 averages together. The fact that I did some magical formula to calculate those averages, you don't care, right? At the same time, a lower level algorithm would kind of say, oh, okay, actually, I'm going to take in the input for everybody, and then I'm going to specifically know how to calculate the average, then take the top 5 of that, and then add those together, right? So it's kind of specifying the algorithm at different levels there, okay? Yeah, so algorithms building on functionality previously defined and known to the user, right? So if you have like something like this, right, you can do division, right? And you might say, well, I should know how to do divide, right? That's something that's kind of part of my library, my repertoire, right? So you're kind of reusing that, right? Again, it's almost similar to like the first point about different levels of your algorithm, but it's basically building upon, it's like algorithm building on algorithm, right? So I'm not going to necessarily sit there and like every single time figure out like, okay, what is the steps or algorithm to do divide, right? You know how to do divide, right? So there's potential to have multiple ways to solve a problem, right? Multiple ways to reach the same conclusion no matter what the inputs are. So same input always generate the same output, and it could be done in different ways, different sequence maybe. So it depends on what thing, but yeah, there's a potential for that to happen, okay? So I'm just going to kind of talk through this, and you can kind of maybe follow along and think about it and see what that means, right? So, you know, we're obviously all not sitting in the class right now, but, you know, just imagine everybody stood up, you assign yourself number one, and then you find someone else that's standing, you know, add your number to that person's number, right? And then store the result, right? And then one person sits down, the other person is remaining standing. If you're still standing, then you go back to step 3, find someone else, okay? When they say assign yourself to number one, everybody assign themselves to number one, okay? All right, so you can imagine, what is this algorithm doing, okay? Assuming everybody, you know, remembers what number they are, right? So you have stuff, you know, you're all number one, you find someone, you're basically accumulating these numbers up until the point where at the end, you're going to get the total number of students in the class, okay? I hope people can see that, right? But that's an algorithm, right? So don't worry so much about this. There's just kind of like a goofy, like, you know, thing here in terms of an algorithm. Think more about this as like a flow chart, right? So what you care about is the flow chart, which is the next thing that we're going to cover in the class. You know, so you have these different little boxes here, right? You have like these little diamonds and stuff like that, right? We're going to be a little bit more precise about this when we get into flowcharts, and I'm going to be covering flowcharts as part of this lecture. So yeah, you just kind of follow these steps here, and it's represented in a flowchart, okay? Algorithm, follow this algorithm, and then it's represented in this flowchart like this, right? So let's step into that. So there's a couple of things. You might see this, you might see flowcharts a lot of different ways, but this is kind of like the quote unquote basic or standard way to look at things. And, you know, there's some convention on this. So we have the start and end point for your algorithm as this oval shape here. Then you have these directional arrows that kind of, usually we kind of lay it as going from top down, right? So, you know, at the top, usually we'll have the start oval, and then you have like this arrow that kind of flows down. You know, input output, that basically represents like, maybe I'm like typing into a keyboard or something like that. So that your input and your output might be, let's say, to your monitor, to your screen or something, right? The process could be a calculation, adding 1 + 1, something like that, right? And then your decision is generally like the convention that we're following, and you want to stick to that. Remember that when you're doing your flow chart, you know, so do binary. It's a binary thing. So it's yes or no, true or false, something like that, right? So this is like a common area that people kind of get tripped up on, is if you put in here, say, oh, small, medium, large, right? So I have a t-shirt, let's say, and I'm going to have, you know, sizing for particular people, and your t-shirt size is a small, medium, large, and then they'll kind of go into this diamond and they'll kind of break out small, medium, and large. You can't do that, or you shouldn't do that. That's not the convention we're following. we're kind of following a convention where it's binary. You only have a choice of left or right, true or false, you know, 0 or 1, right? Something like that, right? So in this case, where you have 3 choices, right? Small, medium, large, you might start something with like, is it a small or a medium, right? You know, the person, no, actually, I shouldn't say that. Is it a small, right? And then is it, if it's a small, then it's yes. If it's a no, then it would go to, well, is it a medium, right? Then that also becomes a yes or no diamond. And then if it's a no, you could do one of 2 things. Then you can say, oh, is it a large? Or you can assume that, well, if it wasn't a small or a medium, then it's a large. Okay, so there's a couple ways you can look at that, but the bottom line is you cannot do, or you should not be doing a single diamond to kind of go in there and say small, medium, or large coming out the other end. That's your choices, right? It's a binary thing. So the way I would lay this out when you do your flow chart for your assignment, let's say you have to do 3 choices, which I know for your assignment you do have to do 3 choices or 4 choices or something. You go through each one and say yes or no for that one. And if it's a no, then you go to the next choice and say yes or no, right? So you kind of chain these diamonds together, okay? So like I said, let me repeat that. You know, if I have a choice of small, medium, large, right? I'm gonna first check small. Is it small? If it's not, then I'm gonna say, is it a medium, right? And if it's yes, that's good. If it's not, then I'm gonna check, is it a large, right? And assuming, and maybe it's never good to assume something, assuming that it's going to be a small, medium, and large, that's, you know, that's the end of it, right? You could put in like an error checking type of thing, right? To kind of say, if it's not a small, it's not a medium, it's not a large, then it's going to go to an error box and it's going to say there's an error because you put in a size that is not valid, okay? So keep that in mind. The reason why I'm mentioning this is because this tricks up a lot of people when they work on the flow chart for the assignments. Okay, yeah, that's the reason why you have these directional arrows, right? So all your steps should be in logical order, right? So there's a flow to it, hence flow chart, right? So your arrow is pointing to the next step and it kind of flows down from top to bottom usually, okay? Yeah, clean, neat, easy to follow. That's part of the reason why we kind of make it so you have like, you know, your diamonds that you only have like the two lines going out, right? And it's repeated here and it's kind of in bold, right? The reason why it's in bold is because almost every semester we teach this, we always get like things get messed up over here, right? Always 2 lines out. So remember that. Yes, no, true, false, something like that, right? 2 lines out, remember that. Your input and your output process, 1 line in, 1 line out. That's another important point. Make sure you do that. And your start and your end, right? 1 line out, 1 line in. So keep these type of things in mind, okay? And I'm gonna actually add one thing to this in a second here. So brief statements, yeah, you can put like some pseudocode or some, you know, statements inside the symbols to kind of talk about what you're trying to do. So this kind of sums it up, short description of the statement that you want the computer to do, okay? So let's see here. Oh, I should put a name here. That would be good. I guess it doesn't matter. Let me just put flow. Okay. So you can see it's same type of thing, right? Talking about lamp and light bulb and whatnot, right? So you have these arrows like this, and it doesn't have to start and end, but let me go here. Come on. Cool. Okay. Something like this. Kind of messing that up there. Yeah, I'm just going to take this here. Here. Like that. And let's say for the sake of argument, you had an output here. Okay. Like this. And where's my oval shape? Let's stick that here. Okay. So what you want to do, this goes back to my point, like in the previous slide where you have like one out or one in. So you see, and don't forget about these descriptions here, but let's say I'm doing multiple things here and I wanted to kind of finish up here at the bottom, right? So, you know, based on like what I just said in the PowerPoint, you're not going to do this. You're not going to do this down to here and come on. Don't do that, okay? For exactly what we were just talking about here, right? Start and end is one line in, right? So don't do that. So what you want to do is, do I have a little dot here? There's a little dot. Okay, normally I would find a little dot on here somewhere, but so what I would do is something like this. Okay, I'm kind of doing this pretty quickly, but normally it would be kind of like I would do this right angle this way, and then I would come down here, do another right angle and bring the two together. And then I would come from this point here to make this one here. Okay. So, and the reason why I'm specifically telling you this is to keep this in mind when you do this for your assignment. This is how you should make sure that there's only one input coming into your end oval shape here. This is your end here. Okay. And in case you don't remember how I got here, basically I did draw.io. So draw like that. Okay. So when you start working in your flow chart, you can do something like what I just did here. Okay. But hopefully you can see what I'm just showing you here. You can see the input one, and you can see like your two output, yes and no, right? And then you can see when I finish, you know, I might have taken these two lines like this, brought them together. I should look at this later on, but there should be like a little dot or something I can draw as an intersection of these two here. And then from that little intersection, connect that to do one output here. Okay, so you can argue like whether you need to do that way, but that's our convention. So you should follow that. Okay. Where's my PowerPoint here? Okay, so pay attention to this when you're doing flowcharts. Okay, so flowcharts, algorithm, they kind of go hand in hand, right? This is a way to visualize the algorithm a bit. And then, so usually the way we work it, right? It's not like in real life, you might always do it that way, but it's kind of a nice way. You can look at the flowchart. People can kind of look at it together. They can brainstorm over it, work things out, and then someone will come along and say, okay, let's translate this flowchart into a real program, into some code, right? And that's where we get into like pseudocode and whatnot. Okay. Yeah, there's like some pseudo code here. I'm not gonna go through this. So this might be a little bit better way to look at it, right? So you have like this flow chart here, okay? And then alongside it is like some sort of like algorithm or pseudocode, right? Pseudocode is obviously pseudo. It's not your real code. But you get this type of information, right? IO, right? So this is input output. So you do this as your input. You go into this URL, facebook.com, right? You're going to do a login, right? So this is your process, right? And as I'm talking over here, you can look over to your right. You can see the matching things here, right? And then you get your page, okay? You're going to get your password and your ID. And you can say, is it a good password or is it a bad one? Or ID, right? Whatever, right? So you're down here, right? And then if it's not, then you're going to come back up to here, have an error message, and you're back to the login screen. If you got a good password, then you're going to go to your homepage and you display your homepage, right? This is the process, loading the page, and then displaying as your output, right? And then your end here, your oval shape. Okay. Yeah. So you can kind of think about this. I'm going to actually step into this. We're going to base some of our other PowerPoint or some other JavaScript on this thing, right? Converting temperature, right? Or calculate the number of hours worked and pay per hour, right? So these are some things we'll build off of into future lectures or future code that we'll do, JavaScript basically. I mean, I kind of actually did this also in Excel also. But yeah, so these are a couple of problems. And yeah, so you have something like this where you have some script. This is kind of stepping into, some calculations here, given like your, you're building on your HTML now. You're stepping into JavaScript land and starting to do some calculations, some work there. So what's the distinction between HTML and doing JavaScript? HTML is basically kind of like formatting different things, right? So you have your text, or you have a table, you have some colors, your fonts. It's basically how the thing looks, right? JavaScript is more into like manipulation, calculation, stuff like that. So doing transformation, right? Storing stuff, doing whatever. So that's the distinction between HTML and doing JavaScript, right? At least for our class. There's other things that people may do for, either their programs or for their web pages, right? But in this class, that when someone says, okay, what's the difference between HTML and JavaScript? That's the distinction there. JavaScript is for your meat and potatoes, your calculations, your storing of data and whatnot, and do things with it, right? Just like here, you can see I'm calculating the Celsius by doing Fahrenheit, a little bit misspelling. Is that how you spell Fahrenheit? Yeah, Fahrenheit, do the calculation here to calculate your Celsius here. Okay, so this is what we are talking about, your calculation, that's your JavaScript. When you want to say, oh, I want to make this a big font size, or I want to make this a certain color, I want to make it bold, I want to put it in a table, that's your HTML. Okay, so that's how you can draw the distinction between your HTML versus your JavaScript. They hang together, they work together, right? They're just doing different functions. Okay, calculating your hours and how much you get paid based on whatever your pay rate is, right? So you work 20 hours and you get paid, I don't know, $15 an hour. Then you take your total pay would be your hours times your pay rate, right? Alert is just your display. This will just pop up something to say what your total pay is right here. Okay, so simple stuff. Here's the flow chart that goes alongside of it here, right? And this matches up to like basically simple, JavaScript code that you're doing here. Okay, right. And then there's this algorithm for doing overtime, right? So if you go beyond 40 hours, like right here, you go beyond 40 hours, you're going to get time and a half over here, right? If it's less than 40 hours or equal to 40 hours, you're just going to take your hours times your normal pay rate. Okay, and you can see how it comes together like this before it went to your total output pay. Okay. All right. So fundamental concepts expressed in JavaScript. Okay. Well, what you saw here is essentially, your first introduction into JavaScript, right? We're doing like these little calculations here. Okay. Yeah, a lot of words here. I'm not going to repeat all of them. I think you can kind of see all of these different things. But basically, for the first part of JavaScript, we're going to talk to you about the idea of what are variables. What are the conventions that we might follow for variable names, the idea of doing initialization of these variables, how do we declare these variables. These are called data types, like, what do those variables represent? I like to think of variables as like buckets, right? And you can say what type of things can go into that bucket. Are they numbers? Are they strings? Or like words, right? Boolean is like a true false, right? Boolean is two states, true or false. Okay. The idea of assignment statements, operators, right? I'm going to just stick with that right now. Let's see how far we can go in today's lecture with this. Okay. So script, right? You might have noticed up here, script and script. That's basically telling me JavaScript, right? That's where I'm going to be putting the JavaScript. So that's the tag that you care about. And so you can put them up in the head level, or you can put them in the body down here. And there's probably what I would say good practice or good convention as to when you put stuff in the head and when you put stuff in the body. But yeah, you can put them in either place. It's fine. Okay. List of statements. Like I said, you kind of saw that up here already, like that. Okay. And yeah, you can do with the semicolon, terminator statement. Okay. Case sensitive. Oops, scroll past it. And this goes back to the other idea I talked about earlier in the class, syntax versus convention, right? So it's not like when we talk about convention, there's nothing syntactically within like the browser or, in other languages, the compiler that forces you to do something. But, for other people that have to look at your code or, support it, we follow certain conventions. Okay, makes it easier for you and for other people working with you to understand what you just wrote. Okay, so rules of the road and general agreement. I guess that's kind of rehashing the idea of syntax versus convention. Okay, so yeah, they use these little Tupperware boxes, I guess. Are these Tupperware? Whatever these plastic boxes are, as like variables, right? So a variable, like I said, I think of it as a bucket, but it's really a memory location. Okay. Memory location, and so the name of that bucket, right, or the name of that location is different from what's inside the bucket. Right, so I can call this bucket A, right, but it doesn't say what actually is inside that bucket. That bucket, what's inside the bucket could be something else, right? So the name is separable from the value. Okay, and then syntax. Syntax means like the JavaScript will not work properly unless you do that. Okay, so you want to start it with a letter, right? And then any sequence of letters and numbers. You can have underscore in there. You can have a $sign in there. Okay. And you can't have spaces, right? I know like you might be used to having spaces like in your file system or something like that, the names of certain things on your file system. But for JavaScript variables, you cannot, right? So these are like things you want to remember, right? When you get to your second exam, we'll kind of be giving you lists of things and telling you, are these valid variables or not? Okay. And, valid variables is important, right? Because you don't want to end up using certain keywords or doing certain things that will confuse the computer, and then you won't behave the right way, right? And it's going to be a pain. I think there's one aspect of this where I'm gonna talk a bit about how do you debug code and stuff like that, but I'm not going to cover that today. So your convention, so be descriptive, right? So in the old days, people used to call like variables, kind of say, oh, variable A, B, C, D, right? Because you're kind of lazy. You just want to put in like one letter and do that, right? The problem is like when you don't have like any description on it, later on, someone's going to say, oh yeah, we're storing stuff in variable A. Well, what is the stuff that you're putting in variable A, right? There's no correlation, right? So it's almost like documentation to kind of say, oh, we're going to call this variable car. Then chances are like it's going to have the name of a car in that bucket, right? On that variable. Be descriptive, right? And this is where we get into like the idea of camel case, right? So the first letter is lowercase, right? So you can see this tax, right? Lowercase tax. And then you have, when you change to another word, you can see they made a capital A here, right? And so that's the idea of like camel case, right? So tax would be lowercase, right? And then capital A and amount. And I don't know, let me, something like that. So anytime you change word, the first letter, you would put in like a capital, right? Now, that's a convention. Like your JavaScript is not going to break if you make this a lower a, right? You say tax amount, all one word with no uppercase A, nothing's going to happen. This is where it's a convention. It makes things easier for people to read. Like someone else is looking at this and can easily see that you're talking about tax amount. Okay. So this is important, right? This will be something that we're definitely going to test you on the exam, and you're going to have to be able to do this when we do your assignments, right? So understand what the conventions and syntax are for variable names in JavaScript. Okay, so this is for you on your own. You can take a look at this, and you can look at this. This is something I kind of asked people to do on the side was, show me a camel case example with a 3-word variable, right? Very simple type of thing. You can kind of think about it on your own, do it on your own for yourself, right? Self-study, right? But here we have like day of week, right? I'm not gonna go through each of these and tell you legal or illegal, but you can look at this pretty quickly and you can kind of see for yourself whether you think it's legal or illegal. Okay. All right. And here we go. Right. So you got legal, illegal, legal, illegal, legal, illegal. Okay. And then it kind of gives you the reason here. Okay. So I hope all of this kind of makes sense based on the rules that I just told you up here. Okay. I put this out on a slide, so you don't have to write this down. You can just kind of take my PDF that I put up onto Canvas. Yeah, but do study this part. Just make sure you understand like this stuff here. What's a legal variable? Okay, so more on variable here. Okay, so E and F kind of doesn't mean anything, right? And then you have an area here, right? So you might want to have something more meaningful here. Okay, so let's look at what might be more meaningful. Yeah, well, E could be a height. That kind of sounds pretty meaningful, right? So when I reference E, I'm referencing the height of this shape here, right? Likewise, I'm looking at F. Maybe I should be calling it width, right? So then I'm going to be taking the height times the width to get me the area. Okay, so this is what they mean in terms of good practice, making the identifier something that has some sort of meaning here. Okay, it's almost like your documentation. All right, this might be even more meaningful. right? You can talk about blue height, blue width, and blue area, okay? Depends on the situation. You may or may not go that far, but just some ideas on how you create meaningful variables, okay? Here's my little Tupperware or plastic boxes here. So here's the variable, right? var, right? This is how you declare a variable. So this just tells the computer that I want to create a bucket called age, right? I want to create this little variable called age here. So this is what I do. I do var age semicolon, okay? And the same thing for area and same thing for radius, okay? And so this is trying to tell you that you can declare multiple variables in one shot, right? So here you're declaring them one by one. Here you can do it both in one shot like that, okay? And when I declared it like this, the values haven't been assigned yet. So I haven't put anything against them, right? So I haven't put in like age equals to 23 or something like that, right? So these are just empty buckets at this point, right? There's nothing in these buckets. Now, this is what I was mentioning before. There's different types of data that I can put in here. I can put numbers in there. I can put strings in there. And I can put Booleans in there, true, false, right? So this is important, right? This is called your assignment, right? Which is the equal sign, right? So here, I've declared these variables, and then here, I've assigned them, right? So that's the difference between declaration of a variable and assignment, okay? This one I'm saying balance due equals to 0. And this one is 0.088, okay? Now, the other thing you can do is at the same time you're declaring it, you can initialize the variable, right? Or assign the value to the variable, right? They're both the same thing. Either you can call it initialize or you can call it assign a value, okay? So var balance due equals to 0, okay? And then likewise, you can do multiple variables to declare and assign or initialize just like so, okay? So what you see down here is the equivalent of what happened up here, right? Except they did it one line at a time. Here, they did it all in one shot down here, okay? So that's how you do declaration and initialization or assignment of your variables. Okay, so this is important, right? So especially if you're kind of like used to mucking around with things in Excel or whatever. This is how you represent percentages, right? It will be 0.33 as opposed to saying 33%. Okay, don't get this mixed up when we do go to Excel, because in Excel we can do both, right? But we might format something to be a percentage, and then this is exactly what you would see, right? You would see 33%. But I'm kind of going ahead here. So your currency, right? This is what it's going to be stored as. It's 10.89, right? There's no like $ thing in there, right? So at least for JavaScript, you're not having this idea of like a currency thing. And of course, you're not working with commas here. So this is kind of like a formatting thing. If you want to show this in your browser, you're going to have to do your own formatting. What it's actually stored as is this. Okay. And same thing as this, right? See, no comma here, right? No comma there, right? All of this comma stuff, the $, the percentages, this is like stuff that you would do as formatting. What is stored as in your memory, in your variables is this, whatever is on the left side here. All of this stuff here on the right side is what you get after you do some formatting on it. Or it could be rounding, right? You might be doing rounding on things too. This is like for writing strings or storing strings, okay? I'll get into this a little bit later about this whole single quote, right? Versus like double quotes here. You know, this can kind of trip you up a little bit. So you can see like this backslash here. that's like a escape character, similar to the ampersand sign when we're looking at the HTML. Okay. You can do arithmetic operations. So I'm storing numbers, let's say, in my variables. Then I can do your standard stuff, right? Addition, subtraction, multiplication, division, whatnot. Your multiplication is this asterisk sign here. Okay. If you might remember from our binary conversions, we're looking at the remainder, right? That's your mod. Maybe you remember that from math. So you're going to do this mod, which is this percentage, and what comes out is the remainder, right? So you care about the remainder. And the math here follows the same thing as what you might have learned in high school in terms of PEMDAS, right? And basically, you're going to start off with your parentheses, whatever inside your parentheses, that's what you're going to process first. Then you're going to do your exponents, multiplication, division, addition, subtraction, right? So PEMDAS rule. So when you put together a complex formula, you start mixing these things together, it's going to follow the PEMDAS rule, which is kind of what you would expect, right? That's a standard thing. Okay. All right. So I know I probably talked pretty quickly and went through all this stuff, but this is your basic intro to JavaScript. Again, I'll repeat, this is not on your first exam, your exam coming up. So what's coming up will be the stuff I covered earlier in this lecture, right? All this stuff up here, all the way through is for exam 2, okay? Right, and this is essentially covering flowchart, covering algorithm, covering pseudocode, and introduction to JavaScript, variable declaration, variable assignment, initialization, the conventions we follow for variables, math that we do for JavaScript, strings, and PEMDAS and whatnot. Okay, so that kind of covers what we're covering here. So what are strings? Strings are basically like words, right? So where am I here? So like all these are numbers here, right? So the age is probably some number, area is some number, and radius is probably some number, right? But let's say I have a variable called name, right? What is in the name? Probably not a number, right? Probably whatever name I can think of, like, I don't know, Jake, right? So I have a variable, I have a name. What do I put in there? It's a string, and the value is, let's say, Jake, right? So that is, just a type of what will go into each of these buckets, right? You have numbers, you can have a string, which is basically like a word or something, right? It could be multiple words, right? It could be a space. A space is a string also. And you also have Boolean. A Boolean is true or false. Okay. So hopefully that makes sense. Yeah, so is my name and my underscore name the same thing? No, it's not, right? If I name two variables that way, it's two different things. I'm just gonna type here so people can see what I'm talking about, right? So if I say var equals to, no, not var equals, var my name versus var my name. Those are two different variables there. Okay, so and I would reference them that way, right? Are they valid? Yes, they're both valid, right? So these are valid names. You can follow whichever convention, right? Some people like to do these underscores here, right? Remember, this is camelback, right? Camel convention here for your variable name here. But yeah, this is not equals to that, right? There's some other tricky things in terms of what goes into these buckets. I don't want to cover it for this lecture, but hopefully that answers what some of the initial things about JavaScript and like variables and how you work with variables. Okay, cool. Does anybody have any other questions and whatnot? You don't have to do it here. You can feel free, send me email or whatever. Any questions you might have for the upcoming exam and whatnot. I am working through the exam right now, reviewing it with the TAs. So we should have everything lined up for you for your exam for next week. And I'll get into more details if there's anyone having any questions about how we're going to run the exam. But it's going to be online. It's going to be on Canvas, right? So you'll kind of open it up. You'll see, just like when you go to your assignments, right? There'll be the exam that you can go to. The first part will be multiple choice, right? And when I say multiple choice, that also means true, false, same type of thing. And then there'll be a part for you to submit short answer, right? It could either be typing it in, or it could be taking a picture of your HTML or uploading it. So that will be out there too. Okay. Any other questions that I can answer? Cool. Okay, well then I'm going to let you go. Enjoy the rest of the night, and hopefully I'll talk to you again soon. Enjoy the weekend. Okay. Thank you.